Hello everyone, welcome to Neso Academy. In the previous lecture, we understood digital design process and how VHDL is used in that design process. But one question still remains. How is VHDL different from other programming languages like C programming and even Verilog? Because many students ask why we are using VHDL if we have Verilog. Which is better, VHDL or Verilog? And so many confusion. And that confusion can lead to bigger problems later. So, today's lecture is all about VHDL, Verilog, and C programming. Therefore, the name of the lecture is VHDL versus C versus Verilog. So, I hope you are excited for this lecture. In this lecture, we will cover the following topics. The very first topic is VHDL versus C programming. That is, one hardware description language versus software programming language. Then, second topic or last topic of this lecture, VHDL versus Verilog. One hardware description language versus another hardware description language. So, let's start with the very first topic, VHDL versus C programming. Now, at first glance, both look similar because both involves writing code, but internally they are completely different. Means VHDL defines hardware structure while C defines software behavior. Let's see the purpose of each language. VHDL describes digital hardware circuits and systems similar to schematic diagrams, in which VHDL is used to design and simulate digital circuits or hardware, while C programming develops software algorithms and instructions. Means C programming describes set of instructions or software that a CPU must perform. Means writing software programs. So I hope it's clear that how internally they are completely different. Let's see their execution style. VHDL executes statements concurrently in parallel. That is, multiple operations happens at the same time. For example, if I want to start a hardware device, now what I need that every component in that device should start simultaneously at the same time for proper working. However, VHDL supports both concurrent and sequential execution because we all know that VHDL combines features of different design styles or different languages such as concurrent language and sequential language. Whereas in C programming, statements executes sequentially, step by step. For example, in a code where first line is A equals to 5, second line B equals to A plus 2. Now, first A is assigned, then B is calculated, one line after another in series. So, here we understand that C programming is sequential programming, whereas VHDL supports both concurrent execution and sequential execution. Now, let's see the third difference based on syntax. That is very much important. Now, VHDL is verbose, based on ADA-like syntax, whereas C programming is concise, structured syntax. Now, VHDL is based on ADA language, which itself is influenced by Pascal language. Now, ADA language was developed by US Department of Defense for massive and high-stake military designs, whereas C was created by Dennis Ritchie at Bell Labs. It was designed primarily as a system implementation language, which was highly structured, means it is very organized. Now, what is verbose and conciseness? Verbose means containing much more number of words than needed. as VHDL is based on ADA language. It was used to design high-stakes systems where clarity and safety were much more important than speed of writing. Whereas C was designed as a system programming where efficiency and speed was much more important. Now, what that mean? It means in VHDL, you have to be very loud about what are you doing. You have to explicitly tell about everything, about every entities, libraries, architecture, about everything that you are writing. While in C programming, compilers assumes a lot for you. You can often write operations with very less number of reused codes. That is, in concise manner, means short and crisp. So I hope you understand that VHDL is verbose and C programming is concise. So far, we understand the purpose, execution style, and syntax. Let's see the difference based on timing specifications. Now, VHDL explicitly models time and propagation delays. Now, as we know that VHDL programming helps in hardware designing, where timing constraints and propagation delays are very much critical. While C does not model any hardware timing directly because there is no any direct connection with digital circuits. So, timing specification is very much important in VHDL, while in C programming, it is not important. So, overall, VHDL synthesized into hardware netlist. Now, we all know what is netlist. Connection of logic gates. So, VHDL is used to synthesize into hardware connection of logic gates, while C programming compiled into machine code, that is, software program which is executed by a processor. So, I hope you understand the difference between VHDL programming and C programming, where VHDL describes hardware behavior and C programming describes software execution. So, in this way, we have completed our first topic, VHDL versus C programming. Now let's see our second topic, VHDL versus Verilog. Now VHDL and Verilog both are hardware description languages, but there are some difference based on syntax, style, and philosophy. So let's start with their origins. Now we all know that VHDL was developed in the 1980s by the US Department of Defense, and Verilog was developed around same time by Gateway Design Automation. Now the purpose to design Verilog was to create a simulation-based hardware description language that was easy to use with existing tools. So I hope the idea of origin is clear to you. So let's see the difference based on syntax. Now we have seen that VHDL is based on ADA and Pascal language, which are strongly typed. And Verilog is C-like, simpler and weakly typed. Now what is strongly typed and weakly typed? Now VHDL is strongly typed, means it is very strict. In VHDL syntax, you cannot easily add an integer with a bit vector without conversion function. So, this syntax forces you to acknowledge that you are changing data type. It means that in VHDL, you have to specify each and every data type. Now, that is called strongly typing. While Verilog is very much relaxed, similar to C. In Verilog syntax, you can add a 4-bit vector to an 8-bit vector. So, Verilog is very much flexible. Here, we don't need to specify each and every data type. However, it may result in internal bugging. Whereas VHDL philosophy, it's better to have compiler error rather than silicon error because manufacturing a hardware is very much expensive. So, here we understand that VHDL is strongly typed, while Verilog is weakly typed. Now let's see the difference based on case sensitivity. So VHDL is based on ADA and Pascal language, which are generally case insensitive. That is, names for variables, signals, keywords, entities. Example, capital my signal, small my signal, and this my signal all are same, which represents a same object, while there are some exceptions. Characters like capital X and small x are different. String literals like data with capital D and data with small d are different because they represent different values. While in Verilog, capital my signal, small my signal, and this my signal all are different because Verilog is case sensitive. So here we understand that VHDL ignores cases while Verilog does not. So I hope this point is clear to you. Now let's see another difference based on levels of abstraction. VHDL supports high level and more readable, while Verilog prefer low level and closer to hardware. Now what that means? Let's understand this. VHDL and Verilog both are hardware description languages that can be used to design systems at various levels of abstraction, starting from high level to low level modeling. Now we all know that what is high level abstraction and low level abstraction. As VHDL is more verbose, more strongly typed, it is useful for complex designing. So it supports high level abstraction or system level abstraction, often preferred in military and medical industries where long time maintainability is critical. While Verilog is concise, weakly typed, means closer to hardware. Therefore, it supports low level implementation or gate level abstraction. So, VHDL and Verilog both are hardware description language that can be used to design systems at various level of abstraction. But for high level, we prefer VHDL, and for low level, we prefer Verilog. Now let's see another difference based on design approach. VHDL emphasizes simulation, synthesis, and documentation. Now, as we have seen that VHDL is used for high-level abstraction or for complex designing, therefore documentation is very much needed. While Verilog focuses on simulation and hardware synthesis only, no documentation needed as it supports low-level abstraction. Now, so far, we have seen the differences based on origin, syntax, case sensitivity, levels of abstraction, and design approaches. Let's see the difference based on data types. Now, VHDL has rich and extensive data types, while Verilog has limited built-in data types. Now, VHDL is strongly typed, therefore, has rich and extensive data types, such as scalar types, which includes bits, standard logic, integer, boolean, and other which includes arrays. So, VHDL also allows designers to create custom data types, such as enumerated types for finite state machines. Now, what is enumerated type? It is a custom integer. For example, switch on represents by 1, switch off represents by 0. While Verilog is weakly typed, means it relies on smaller set of predefined data types, which mainly categorize into nets. Example, wire for physical connection and register that represents data storage. So here we understand that VHDL has rich and extensive data types and Verilog has limited built-in data types. Now let's see their uses. VHDL widely used in Europe for aerospace and defense, whereas Verilog is widely used in the US for ASIC and FPGA designs. So there is no debate that which language is better. It's all about the area of uses of each language. As we can see that VHDL is used for complex designing in aerospace, defense, or medical industries, whereas Verilog is used for low-level abstraction, therefore used in ASIC and FPGA design industries. Now, let's see an example of NOT gate. Let's design this NOT gate using VHDL coding and Verilog coding. Now, this VHDL code represents NOT gate. Start with library, use clauses, then entity declaration. Here we define inputs and outputs. Then we have architecture. In architecture, we describe the overall structure or circuitry of the gate. Now, we will understand about this structure in much more details in upcoming lectures. Now, let's see the Verilog code for NOT gate. Over here, we can see there is no library declaration, nothing called as entity or architecture. Start with module declaration with input and output, then assignment which describe the structure of the gate. So, I hope you understand the difference between VHDL coding and Verilog coding. So, in this way, we are done with our second topic, VHDL versus Verilog. So, in this lecture, we saw VHDL versus C programming, where VHDL describes hardware behavior and C programming describes software execution. Then we saw difference between VHDL and Verilog, where VHDL is much more structured and readable, while Verilog is simpler, closer to hardware. And I really hope you understand everything. Which means we are done with this lecture. I will see you in the next one. Thank you.